Hello, very welcome back. And on your screen, you see an analog circuitry realized using a transistor and the resistor. So this is basically a circuit in analog domain used to realize digital logic, and this logic can be called as RTL logic. So we see that RTL logic, and RTL stands for resistor transistor logic. So since, as I said, there are resistors and a transistor, this is a RTL logic. So what you see here is one BJT, that is NPN transistor. Here you would like to see and mark your terminals here. For example, let us mark the pins of the transistor. This is, let's say, the collector. This is a base, and this is an emitter of the transistor. Similarly, you also want to understand that this is an NPN transistor. So this is N, this is P, and this is N. And what else you note here is that you have got resistors R3 and R4. There is this resistor R1 and there is this resistor R2. Output is taken from the pin collector labeled as Q, and the R2 is connected between pin collector and the highest supply voltage in the circuit. Emitter is connected to the ground. From the base pin to the negative supply voltage, you have resistor R1. This resistor R1 is used to bias the transistor at a proper operating point. So you have got negative voltage here. So there is some negative voltage coming at the base pin. And since the emitter is at ground, you can see that this junction, that is base emitter junction, that is voltage drop across base and emitter, VBE, is less than zero, and therefore this junction is reverse bias. Okay, this junction is reverse biased. Now, since the junction is reverse bias, we want to understand how we'll apply the inputs. Input A and input B, they are connected to the base through the resistor R3 and resistor R4. So we would be applying either logic 0 or logic 1 at A and B. So logic 0 means lowest supply voltage, and logic 1 means highest supply voltage. So we'll be basically using this circuit as a switching transistor circuit. And this is the label of the transistor Q1. So we now try to see how this RTL logic will work. And that we can do by applying some logic levels. So let us say you apply 0 and 0, that is logic 0 and 0. It means at the base you have got a 0 volt. Here it is 0 volt emitter. So there is no voltage difference between the base and the emitter. So this junction is reverse biased and the transistor is cut off in the cutoff region. Since this junction, since the transistor is in cutoff region, there is no current flow through the collector of the transistor, and transistor is said to be switched off. So for that combination, you want to write a kind of truth table. So let us write a truth table here. So let's say you have got input A and input B. There are four possible combinations: 0, 0, 0, 1, 1 0 and 1 1, and here comes your output Q. Okay, so for the 0 0, since there is no current flowing through the collector of the transistor, output Q is equal to the highest supply voltage, that is V plus, and therefore we can say it is logic 1. Now, for the second combination of the input, let us say you apply 0 and 1. A is 0, B is 1. So, since the B is 1, you have got a high level voltage here. So, that high level voltage emitter is at 0 volt, that is ground, makes this junction forward bias, that is VBE is greater than 0.7 volt, assuming the transistor is silicon, this PN junction is of silicon diode. And therefore, since the VBE is greater than or equal to 0.7 volt, which is the forward voltage drop of the transistor here, the transistor is switched on. You have a base current flowing here, and therefore there is the collector current flowing through the resistor R2, the resistor R2. And therefore, there is a significant voltage drop across the resistor R2 and giving a logic 0 volt. Q is pulled down to a 0 volt, that is the ground right over here, because there is a large voltage drop across this resistor. And therefore, you can say that transistor is saturated. So when the transistor is saturated, it is fully turned on, and we would say the logic level Q is 0. How about the combination A is 1, B is 0? Similarly, because A is 1, there is the base current flowing right over here. There is a high voltage level here exceeding the 0.7 voltage drop across the base emitter junction, 0.7 volt. There is therefore the transistor gets saturated again because there is a IC that flows through the resistor R, causing a large voltage drop across it, making Q is equal to near to the ground level. That is again, you can say the output is 0. How about final combination, that is 1, 1? Obviously, there are two paths for the signal. The two resistors are in parallel here. And therefore, again, you have a positive voltage. The base emitter junction is forward bias. Transistor gets saturated again. Collector current flows through resistor R2, pulling the output Q to the lowest logic or lowest voltage level in the circuit, which is the ground. So again, you have a logic 1 here. So if you observe this kind of truth table, this is a kind of truth table. If you see that this truth table, this logic is 0 actually here. Okay, let me write here very well. This logic is 0. Don't get confused. Okay, so one more time. This is the logic 0. So output of this circuit is 1 only when both of the inputs are at logic 0. The output is 1 only if both the inputs are at logic 0. Otherwise, for any other combination, the output is 0, as you can see from the truth table. So therefore, this truth table, if you can recall, this truth table represents RTL logic, which is of NOR gate. For the OR gate, you have the reverse truth table of this, but this is the logic representing a NOR gate. So what is the symbol of a NOR gate? So it would be like this. You have got this one, and you have bubble here. This is output Q. This is input A, this is input B, and this is your NOR logic. So this is how you actually can use the RTL. Okay, this is, let me write here. This is your RTL logic. So we see that this is RTL logic. Okay, so hope you found this module quite useful. If you did so, share it with others. You can see that through the simple analog circuit by understanding the basic operation of transistor and combination of resistor. We got the RTL logic to create the NOR gate. Try to create some other logics on your own. So till then, stay tuned. Wish you happy learning.